Today we're going to look at section 6.5, which is operations with radical expressions, which you may have already seen before. So let's just first review by simplifying. So I want you to give these three examples a shot, simplify those to make sure you remember how to do that. All right, once you've done so, now let's start looking at our operations. So we're going to start with multiplying. For now, when we're multiplying, we need to make sure that the roots are the same, okay? We will learn how to do it without the same roots, but for now, the roots must be the same. So a square root with a square root, a cube root with a cube root. We can't flip-flop that. Then once they are the same, simply just multiply the radicands together, that's the stuff on the inside, and then the coefficients, the stuff outside, together. Make sure to simplify at the end. You can always simplify before, but you may have to simplify again, so it's your choice. So let's do one example here together. If I multiply, I'm going to do the outside with the outside, so 2 times 4 is 8. Then I'll keep my square root symbol, and we'll multiply what's on the inside together. So remember, when we're multiplying what's on the inside, you're just going to use exponent rules. So 6 times 6 is 36. X to the first times x to the third is x to the fourth, right? We add the exponents. And y squared times y to the third gives me y to the fifth. Now, at this point, we need to simplify. Remember, 36 is a perfect square, so we're going to take a 6 out front. When that 6 goes out front, that's going to get multiplied with the other value out front. So remember that. We multiply the two. So 8 and 6 makes 48. The square root of x to the fourth would be x squared. None left over. And the square root of y to the fifth would be y squared. But we would be left with a y to the first inside. Now, when we're performing our operations, we don't need to worry about any absolute value, okay? Only worry about absolute value when it's just a simplifying problem. All right, let's look at another one together. I'm going to have you try number 4 because it's very similar, and also try number 5. However, just remember with number 5, we're talking about cube roots. So when you're simplifying, look for cube roots. On number 6, here we have really like a binomial, right? We need to FOIL these. So same rules apply. 5 times 5 would be 25. Then we'll do 5 times root 3. 5 is on the outside, root 3 is a radical, so that would just be positive 5 root 3. Next, we would have negative 5 root 3. And then last, negative times a positive isn't negative. Root 3 times root 3, those are both radicals, so we multiply what's on the inside. 3 and 3 makes 9. And now we simplify. So we have 25. The inside terms are opposites, so those will cancel. And then we have minus root 9, which is 3. And 25 minus 3 is 22. Okay, so again, go back to 4 and 5. Multiply outside with outside, inside with inside, and then simplify. Let's look at adding and subtracting. So for adding and subtracting, the radicands must be the same. So that means not only are the roots the same, but what is inside is exactly the same. If they're not the same, we try to make them the same by simplifying. We're not multiplying or anything like that. We're just going to break those up. So if we look at number 7, the good news here is that those radicands are already the same. They're both cube roots of 2x squared. So simply then, we just add the outsides together and we keep the inside. Just like if I was saying 6x plus 1x, we would have 7x, just the coefficients change. So 6 and 1 makes 7, and then we leave the root of cube root of 2x squared. And there's nothing inside that we can simplify, so we're done. Okay? If I do number 8, we see the radicands are different, so we need to make them the same. So remember, 8 is 4 times 2. So if I simplify that, the square root of 4 is 2. That means we'll have a 3 out front and a 2 out front, which makes 6 root 2. Then we'll have minus 5 root 2. There's nothing I can do with that one. And 32 is 16 times 2. So the square root of 16 is 4, and we have our root 2 left over. Now we have all like radicands, so we can actually put these together. 6 minus 5 is 1, and then 1 plus 4 is 5. So we have 5 square roots of 2. You try number 9. Okay, dividing. We're going to look at 2 types of dividing. We're going to have dividing when there's just single terms in the denominator, and then we'll look at dividing with multiple terms in the denominator. So our first thing to do is just to see if you can simplify as is. Can you just reduce that fraction? Can you take the square root or the cube root of both? So if I look at number 10, I can't take the cube root of 40, and I can't take the cube root of 5. But before even thinking about the cube root, I'm just going to try to simplify the fraction. So this would become the cube root of 40 divided by 5 is 8. And x to the 4th divided by x, we subtract those, and that gives me x to the 3rd. So just by reducing the fraction, I've made this problem a lot easier. Now I can actually say, okay, what is the cube root? Well, 8 is a perfect cube. The cube root of 8 is 2. And then the cube root of x to the 3rd is simply just x to the 1st. So we're done. Okay, so this would have been a lot of work to try to rationalize. So if you can simplify the fraction as is, always do that first. Okay, number 11, this time around, we can't reduce 4/5, and never mind even that, we can't reduce it because the 4 is not in a radical, but the 5 is. So to simplify this, we're just going to rationalize. And so we multiply by root 5. I'm going to let you finish that one off to get your simplified answer. For number 12, we're going to rationalize as well. However, if I look at this, can I simplify anything first? So when I look here, I can see the radicals both have a 2 in common. So I can first simplify by dividing both of those by 2. Again, it's just the stuff of the radicals. So that would give me root 6 over 3 root x. It just makes things smaller. If you don't do that, it's not a huge problem. But again, I'm just now going to work with smaller values. From here, we still have a radical in the denominator, which we don't want. The 3 is fine, but the root x isn't. So we need to multiply by root x. Again, you could multiply by 3 root x, but it'll just create more work. The only part that we need to fix is that square root of x. So at this point now, we have the square root of 6x up on the top, and on the bottom we have 3 with a regular x, because root x squared is x. We now try to see if I can simplify. Can the square root of 6 be broken up? No. So here's my final answer. For number 13, we try to simplify that fraction, 7/9. We can't do that. So what I like to do is I like to rewrite this as the cube root of 7 all over the cube root of 9. Now, remember, we're doing cube roots. So that 9 isn't the biggest help, right? It's not a square root. However, the other thing we need to remember is that to rationalize this, it's going to be a little different. I'm not just going to multiply by root 9. First off, that's a square root. In order to multiply, we need to have cube roots. So then the question is, well, do I multiply by the cube root of 9? If I do that, I get 81. Is 81 a perfect cube? No, it is not. So what we need to remember with rationalizing is the point of rationalizing is to either get a perfect square or a perfect cube, or if we're doing 4th roots, a perfect 4th power. The trick that worked for number 11, where I see, I have a root 5, I'll just multiply by root 5, is because it's a square root. So, of course, naturally, squaring a number would create a perfect square. On 13, we need to think about what perfect cube can I multiply? What can I multiply to get a perfect cube? So the next perfect cube, if I'm thinking about after 9, is that we have, right, if I make perfect cubes, we have 1, 8, 27, 64, etc. So can I multiply 9 by anything to give me any of those numbers? And I can. I can multiply it by 3. And I'm going to do the cube root of 3 because we need to have like roots. So now I multiply up top. So in the numerator, we'll have the cube root of 21 all over now the cube root of 27. But the cube root of 27 we know is 3. So now there's no more radical in the denominator. Double check, can I simplify 21 as a perfect cube? No. So here is my answer. All right, let's take a look at when we have two terms. When there are two terms in the denominator, we must use the conjugate. Okay, so our conjugate is where we just flip the middle term. So 4 plus root 3, the conjugate is 4 minus root 3. Negative 3 minus root 6 is still negative root 3, but now plus root 6. So just the middle sign changes. So when we are rationalizing using a conjugate, again, it's because there are two terms in the denominator. Terms are broken up with plus or minuses. Remember that. Okay? So I'll do 15 with you. So I'm going to use the conjugate. So I'm going to multiply by root 5 plus root 2. Once I do this, now I need to use my multiplication properties of radicals and also my adding and subtracting. So we will FOIL the numerator. 4 times root 5, outside with outside, inside with inside, so that's simply 4 root 5. 4 times root 2 is 4 root 2. Root 2 times root 5, those are both radicals, so we multiply the insides to give me 10. And root 2 times root 2 gives me root 4. Now, any simplifying you can do along the way in your head is, of course, totally fine. Now, don't forget that although we just worked on the numerator, and we have some more work to do with that numerator, we still have a denominator. So let's FOIL the denominator. Root 5 times root 5 is root 25. Or again, if you can simplify that in your head right away, do so. Root 5 times root 2 is positive root 10. Negative root 2 times root 10 is root 5 is negative root 10. And then negative root 2 times root 2 is negative root 4. Notice, the whole point of that conjugate is to get rid of any radicals in the denominator. So if we look in our numerator, I can't simplify 4 root 5, so that stays as is. I can't simplify 4 root 2. I can't simplify root 10. I can simplify root 4 to just be a 2. So the numerator still has some radicals, but my denominator, the square root of 25 is 5. And you may have noticed that right away. Root 5 times root 5, the roots just cancel. The middle two terms will also always cancel as long as you use the proper conjugate. And then minus root 4, that's just really saying minus 2. So if we do one last round of simplification, we have 4 root 5 plus 4 root 2. Notice I'm not adding any of these together in my numerator because none of the radicals are the same, and I can't make them the same. And lastly, in my denominator, we have a 3. There's my answer. Okay, you try 14 and 16.